Okay, we're going to look at number 5 now. And I put this problem on here because I just wanted to review with you, how do you handle a problem when there's something, I'll say, odd going on. So I'm going to go over here first, and I'm just going to draw this picture. So this is like a normal XY grid. And let's pretend we had some odd force happening. We'll label this F. So you know that we end up having to take this force and break it down into its components. And the components always have to line up with your X and your Y axis here. So we'll do something like that. So in this problem, it's an inclined plane problem, and we have an odd force happening. But the difference with the inclined plane problem is we're not going to have an XY grid that has the Y-axis straight up and down and the X-axis horizontal. When we have an inclined plane and we turn the object into a dot, we use what I call a tilted axis. So the Y-axis ends up looking like this, and the X-axis looks like this. And so now when we have an odd vector in our problem, we're going to have to break it down into components on these axes. So I'm not going to draw that vector yet because I think it's just going to kind of muddy up my picture here for a minute. So let's just get started with what we know already. So it says that the object has a mass of 210 kilograms. So 210 times 9.8 turns out to be 2058 newtons. All right, let's calculate Fn. So Fn would be going up, but we're going to do the Fn going down. And Fn is obviously Fw times cosine of theta. So that's 2058 times cosine of 35 degrees. And that turns out to be 1685.8 newtons. All right, but we also have this y component here, or this parallel component, Fp. And Fp is Fw times sine theta. And so that's going to be 2058 times sine of 35, and that turns out to be, where did I do that? Oh, right there. 1180.42. All right, but I'm going to take this Fp and I'm going to write it up here. So this is going to be 1180.42. All right, so now I'm going to put in this crazy force that we have. So the crate is not sliding down the hill. It's not being pulled up the hill. It's like being pushed, like somebody's taking their hands and kind of like pushing it into the inclined plane. So probably when you actually push something, that's probably the more natural way that you push something. So I have this crazy vector, just like I had over here, and I now have to break it down into its x and its y components. And the components have to line up with the x and the y axis. So if this is the y axis, then this has to be the y component. So we'll label that Fy. And this here would have to be the x component. But we know the value of the x component because it says in the problem that we're pushing it up with constant speed. It's a frictionless ramp and we're pushing it with constant speed. So if we have 1142 going down, we know that this here, the x component is going to be, 1180.42 going up. So we know that. And once we realize that, we now can solve for this force vector that we're looking for in part A. And by the way, this is like a right triangle here. And using our, I'll say the word geometry, if this is 35 degrees, then this here is 35 degrees. I don't remember what kind of angles those are. Is that supplementary angles? No, I don't know what they're called. But anyways, so it looks like the orange F is the hypotenuse, and I noticed the 1180.42 is adjacent to it, so I'm going to write over here cosine of 35 is going to be the adjacent 1180 42 over F, and we solve for that F, and we get 1441 newtons. All right, part B says, what is the magnitude of the force exerted by the ramp on the crate? So at first glance, it sounds like Fn. It sounds like they're asking about Fn because the crate pushes on the ramp and the ramp pushes back up on the crate. Except we actually have, this pushing down right here, this 1685, but we also have this extra Fy piece over here. So we have to pause for a second. We have to find this Fy. So you'll notice that Fy is opposite the 35. So I'm going to say sine of 35 is opposite Fy over the hypotenuse, which is the 1441. And Fy turns out to be, where'd that go? About 826.5 newtons. I actually used tangent and used a different relationship, so I hope that turns out to be at least close. All right, so to answer question B then, what is the magnitude of the force exerted by the ramp on the crate? So you have two things pressing down. You have the Fn and the Fy. This Fy now becomes another piece of Fn. So two things press down, and that's what the crate's going to press up. So the crate is going to press up with the 1685.8 plus the 826.5, and hopefully that is very close to 25.12 newtons. All right, again, in summary, when you have something odd happening, break it down into the components that match your axes.